All right. We're going to now actually do a full problem of finding your height, finding your latitude at LAN. Now, only problem is they don't give you the time of LAN. Wait, actually, that doesn't even matter. Okay, we're going to do both. Theoretically, it doesn't even matter. Actually, yeah, it does. Okay, it does. They don't give you the time of LAN. All they say is you're in the north. Your latitude is 83 degrees, 33 minutes west. It's January 3rd. And the height of the sextant height at LAN, so when you actually took the shot, it was truly LAN. Your sextant read 61 degrees, 23 minutes. Index error is 0.2 off. Height of eye is 59 feet. What is your latitude? This is all you need, and you can find your latitude. Step one, we need the time of LAN. So how do we find time of LAN? Well, we're going to start by calculating our zone description. So let's see, our longitude, 83 degrees, 33 minutes. So zone description, we do our longitude, 33 divided by 60, plus 83. We divide all of that by 15, and we get 5.57. Meaning we round that up and we get 6. So our zone description is 6. It's plus 6 because we're in the west. So now that we have our zone description, we can find what our central meridian is. It's whatever the 6 time zone is based off of. So you do 6 times 15, and you get 90. So our central meridian is 90 degrees west. Now what we want to find is merpass, the time of meridional passage. So we can compare that to our to the time it passes our shot, or our position. So we're going to come to January 3rd, way at the front of the book. Here's January 1st, 2nd, and 3rd. Come over here. And you can see if it focuses. On the first it was 1204, second was 1204, third was 1205. So merpass was at 1205. Okay. So at 090 west, sun was here at 1205. Well, we're at 08333 west. So if the sun's moving that way, it was at us earlier in the day. So now we just need our DLO, and we can find that. So we'll do 90, 00, minus 083, 33, 60, we get 27 minutes. 89 minus 83 is 6 degrees. So we get 6 degrees, 27 minutes. We do 27 divided by 60. Get 0.45, so this is equal to 6.45 degrees. So now we'll just do arc to time, 6.45 degrees with 4 minutes for every degree of longitude gets us 25.8 minutes, which we can round to 26 minutes. So LAN happened 26 minutes before it did at the central meridian. So we do 1205 minus 26 gets us, 65 minus 26, 39, 11:39. Okay. So LAN was at 11:39 local time. Now that we know that, we can actually go on to calculating our our latitude. Remember, the three things we're comparing is latitude, zenith distance, and declination. So first, let's get zenith distance because it's nice and quick and easy. Remember, for zenith distance, we start with HS. We input IE and diff. That's going to give us HA. Then we input our main body correction, and that's going to get us HO. But now that we have HO, we're going to do 90 minus ZD, or sorry, 90 minus HO, and that's going to give us our ZD. For declination, we're just going to need to take this local time, convert it to GMT, and then find our declination then, at that exact time. So for that, it's going to be GMT, then declination, little d, declination. And then finally, for these two, we're going to then have to figure out what type of LAN problem we're going to be facing. So first, let's get HS to ZD. So HS was 61 degrees, 23 minutes. IE was 0.2 minutes off. Height of I was 59 feet, which is equal to, we come to the first page, go down until we find 58 to 60 is minus 7.5. So dip is minus 7.5 minutes. So then we do 23. I'm going to zoom in a little bit. 23 plus 0.2, because we add for off, minus 7.5. We get an HA of 61 degrees, 15.7 minutes. Now we're going to get our main body correction. I forgot to say, but we're using the lower limb of the sun. Again, like you would, especially LAN of all things, you're really not going to use the upper limb of the sun. So we're using the lower limb. We need our main body correction. So we come to the main section. Let's see. Our HA is 61 degrees, 15.7 minutes. So October to March, April to September. Well, we're in January, so we're October to March. And we're going to follow this down until we get to 59 to 64. And we're using the lower limb, so it's the left side, 15.7. So our main body is plus 15.7 minutes. Happens to be the same value as our minutes already. So we add these two together, and we get 61 degrees, 31.4 minutes. Now, that is our HO. Zenith distance is 90 minus HO. So we're just going to do, well, I'll move this down so we make a little bit more room. Actually, how we write this often is we just do 90 degrees up here. So we convert that to 89 degrees, 60 minutes. And then we write the HO again as 61 degrees, 31.4. Then we write zenith distance. 0.0 minutes. So 60 minus 31.4 gets us 28.6 minutes. Then 89 minus 61 gets us 28 degrees. Okay. So our zenith distance is 28 degrees, 28.6 minutes. Now we need our declination. But before we get declination, we need our GMT. So remember, our local time is 11:39. The second value genuinely doesn't even matter. It doesn't matter what time, what seconds it was. Just 11:39. We know our zone description is plus 6. So our GMT is 1739. So now we need to find what the declination was at 1739 on January 3rd. So we open back up to January 3rd. This is January 4th. January 3rd. we go to the sun. See? Come down to the sun on the 3rd. And we're looking for 1700. At 1700, it had a declination of south 22 degrees, 46.8 minutes. So we'll write south 22 degrees, 46.8 minutes. Then, because it's the sun, we have to look at the little d value. 0.2. Is this increasing or decreasing? Without even looking at this, I can tell you right now it's decreasing because this winter solstice is in December. So if it's January, it's after the winter solstice. The declination is coming towards the sun is coming towards the equator, so the declination is going down. So little d is minus 0.2, minus 0.2. But that's in a whole hour, so we have to come to minutes and seconds, or increments and corrections, because I always confuse them. I always get the two names mixed up. So, increments and corrections for 39 minutes right here. We go to the little d value of 0.2 is equal to 0.1. So that is equal to 0.1 minutes. So now we've got a declination of 22 degrees, 46.7 minutes. Okay, we have our zenith distance, we have our declination. The last thing we need to figure out is what formula we're using for finding LAN. So let's draw a really little diagram. That's the equator, that's the prime meridian. We know we're in the north, so we're just somewhere over here. The sun's declination is 22 degrees south, so it's down here. So then we're going to draw it out again. That's zenith distance. That's latitude. That's declination. So in this problem, latitude is equal to zenith distance minus declination. So we're going to write that out. Zenith distance, declination, and then latitude. Zenith distance is 28 degrees, 28.6 minutes. Declination is 22 degrees, 46.7 minutes. Now, we subtract the two. We carry the 60. So we get 88.6. 88.6 minus 46.7 gets 41.9. Then 27 minus 22 is 5. And we're in the north. So our latitude is 5 degrees, 41.7 minutes. This was a problem where we were in the wintertime, so the sun was in the opposite hemisphere. Remember, we could also have had it in the summertime, in which case we would have added them, assuming that we were north. So you do have to generally know your latitude. You have to know you're not below the sun, which if you're not certain, you can when you take the shot of the sun, if you're looking north, then you're south of it. If you're looking south, then you're north of it. So you'll always be able to figure that out. And you just use the right formula and run through this process. I took 14 minutes because I was explaining all of it. I swear to you, this could take under a minute to do all of this together once you take the shot, especially because you can find the declination in advance. All you have to do, also the LAN stuff, the time of LAN, that's going to be, you're going to predict that potentially the day beforehand, if not that morning. So the only thing you need to do when you actually come time to shoot is you look up the declination, you take the shot, you reduce your altitude sight from HS all the way to ZD, you correct your declination, and then you apply whichever formula you need for LAN, and you instantly get your latitude. When you plot this, It's going to be plotted as an LOP, but you don't even need an assumed position or a azimuth or anything like that, because you just plot a horizontal line at this exact latitude, and that's your position. And that makes it a lot easier during a day's work to just throw that down. That's why people love LAN. It's very helpful.